Hi folks, here's our first review video on the names and formulas of the different compounds that we've studied. And this first video is going to focus in on recognizing what type of compound we're dealing with. Okay, so we know we have ionic and molecular, and I'm going to start with the molecular ones. So the main thing to keep in mind with molecular compounds is that they're formed from two nonmetals. Okay, so let's look around and see if we can find names or formulas that indicate two nonmetals. Okay, and here if I look at the top left, I notice here that I've got sulfur and oxygen. Okay, take my trusty periodic table out and I see that I've got sulfur and oxygen, two nonmetals. So this indicates to me that this is a molecular compound. Okay, now if we take a look at some of the others, well, here we've got nickel, so that's a metal. Here we've got rhodium. If you check your periodic table, that's a metal. Calcium's a metal. Okay, lithium's a metal. Now here we have carbon. And if we look on the other side, we've got chloride. Okay, now the IDE suffix is used for both ionic and molecular compounds, but the other thing we know about the names of molecular compounds is this use of the prefix, okay, to tell you how many of that particular atom there are in the molecule that you're dealing with. Okay, so first of all, I see that carbon and chlorine are two nonmetals, and I also see the prefix tetra, which tells me that this is going to be a molecular compound. Okay, so if you're looking at the formula, look for two nonmetals. If you're looking at the name, look for the nonmetals, but also any prefixes for the number of atoms. Okay, so that leaves us with these four, which all seem to be ionic because of the presence of the metals. Okay, now we know that there's different types of ionic bonds and ionic compounds that we've been dealing with. Okay, first are those that are just made from a nonmetal and a metal. So in other words, a metal cation. Okay, so if we take a look at this one here, lithium, and then a nonmetal anion. Okay, so this positive charge with a negative charge. Okay, this is the standard one, the binary ones that we studied. But we also see, if we look here, that we have certain ions which are actually formed from more than one atom. Okay, so we're going to take a look specifically at these examples in other videos, but here this tells me that I am dealing with an ionic compound, but that my negative ion is polyatomic. Okay, another thing to look for are these Roman numerals. Okay, these Roman numerals tell us that we're dealing with a multivalent metal. Certain metals have more than one possible charge. Okay, all these things will come into play when we're trying to determine how many of each we need to make a neutral particle. Okay, but for now, let's just summarize. Okay, so for our ionic compounds, okay, our main thing here is we have our cation, okay, our positively charged ion with our anion. Okay, most of the time the cation will be a metal and the anion will be a non-metal. Okay, now keep in mind that this is most of the time. Ammonium, which we'll see in one of the examples, is a polyatomic ion which is positive, that is not a metal. Okay, now in our metals we have those with a single possible charge. Okay, things like lithium and potassium and magnesium, and then of course we have our multivalent metals. Okay, so metals that can take on more than one charge. Okay, now for our nonmetal, for our anion, okay, they can be made up of one type of atom, or we have a whole bunch of anions which are polyatomic. Okay, and keep in mind you don't have to memorize these, you will be provided with a list. Okay, and then of course here we have our molecular compounds. Okay, and here we have a nonmetal with another nonmetal. Okay, another thing to keep in mind is that the ions, the ionic compounds, do not use prefixes. Okay, the mono, di, tetra, and so on, whereas the molecular ones do use prefixes. Okay, so you'll use these basic ideas to determine whether you're dealing with an ionic compound or molecular.